So let's talk about conversions of bearings to azimuth and azimuth to bearings. So what you see here is the equations that we'll be using, and I'll go into a more broad explanation of each of these. All right? So here's an example of azimuth to bearing.
In this example, we're asked to convert from north to bearings and compute the angles smaller than 180 degrees between successive azimuths. We've got an azimuth of 68 degrees, 6 minutes, 42 seconds, which is in the first quadrant. 133 degrees, 15 minutes, 55 seconds, which is in a second quadrant. 217 degrees, 44 minutes, 5 seconds is in third quadrant. And 320 degrees, 35 minutes, and 18 seconds is in the fourth quadrant. So 68 is 68 degrees some way out this direction. 133 degrees is out this direction. 217 is out this direction, and 320 is out this direction. So we're going to use these equations here to solve for the bearings. Okay. Now, remember the equations, or remember whether it's being adding or subtracting 180 degrees or the 360. Bearings and azimuths in the first quadrant have the exact same angles. So we've got our equations set up, and here is the layout of the azimuths on the lines. So looking at the first one, we have 68 degrees. So that's this measurement right here. That's our 68 degrees. And we know that when it's in the first quadrant, the bearing and the angles are the same. We're just adding on the northeast. When we're talking about the second quadrant, we said it was 133 degrees, 15 minutes, and 56 seconds. We're measuring from the zero line coming down, and we're going to take 180 degrees. Remember, here to here is 180, and if we take 180 minus the 133, we're going to get south 46 degrees, 44 minutes, 4 seconds east. Now, the next one, we're in the southwest quadrant. So again, we know that this is 180 degrees. And if we're measuring from here all the way to the 217, then all we have to do is subtract the 217 minus the 180 to get the bearing. So 217 degrees, 44 minutes, 5 seconds minus 180 degrees is going to give us the 37 degrees, 44 minutes, and 5 seconds, but it's going southwest. The next quadrant that we're in is going to be the fourth quadrant, our southwest quadrant. So we know that this angle here is 320 degrees, and we know full circle is 360. So we're going to take 360 minus the 320, 35, 18, and it's going to give us this angle right here. So it's going to be 39 degrees, 24 minutes, 42 seconds, but we're going to put northwest on that. So it's north 39, 24, 42, west. Now, the next part it asks is what the interior, the azimuths are. So starting with the 133 degrees and the 68, and I'm not going to say all the minutes, degrees, and seconds. So it's 133 degrees minus the 68 is going to give us this angle in here. Because what we're actually looking at is from here to here is the 68. And let me clear that up. From here to here is 68 degrees. And from here to here is going to be the 133 degrees. When I subtract these two, I'm left with this angle here. So that's the 65,914. Now the next one says, what is the interior azimuth between the 217? So basically I'm going 217 degrees to here. And I'm going 133 degrees from 0 to the line. That leaves me this angle here when I subtract them. So 217.44.5 minus 133.15.56 is going to give us the 84 degrees, 28 minutes, and 9 seconds. Now, the next one we have to do, and this is why it's so easy to use azimuths, we're going to take from 0 all the way to the 217, and from 0 all the way to the 320. When we take the 320.35.18 and subtract the 217, we're going to get this angle in here. That's the interior angle, which is going to give us the 102 degrees, 51 minutes, 13 seconds. And lastly, this is the only one that's a little bit different. Remember, full circle is 360 degrees. And we know that from 0 all the way to here is 320. That means what we need to do is we need to calculate this little bit here and add it to this little bit here, these interior angles. We know that angle is 68. So what we're going to do is we're going to take the 360 minus the 320, and we're going to add the 68. So this angle ends up being the 107 degrees, 31 minutes and 24 seconds.